Right. So yesterday we discussed about Earth's atmosphere. I have told you just right, and I told you that atmosphere of Earth, right, is the uh, envelope of gases around the Earth. That is the atmosphere, and the atmosphere comprises of the you can say gases, water vapor, and particles as well, right? And the second thing we discussed yesterday that due to the difference in molecular weight of the various gases, the distribution of gases, vertical distribution of gases from surface to the space, that is not, we can say, homogeneous, right? So the heavier gases are concentrated near the surface and the lighter gases go upwards. Similarly, the heavier particles in the atmosphere, right? So those are concentrated near the surface of the earth and the lighter particles may go upwards, right? So this was the main thing which we discussed yesterday. Apart from that, many other things were discussed because that was our complete lecture of, I think, 2 hours or more than 2 hours. So that is there, right? So today we are going to discuss the various layers of atmosphere in the earth. But before that, let us discuss one more thing that, right, what is the benefit of atmosphere? Okay, what is the benefit of atmosphere, we can say, right? Or what is the bearing of atmosphere on, we can say, our life, right? What is the bearing of atmosphere on life on this planet? So that is the point which we are going to discuss today. Okay, okay. So that is the point, right? Uh, Anthropogenic causes, yes, to some extent, we can say extraction of more water, wastage of water, all these things, Raviraj. Okay, so but that is not the purpose of, right? We can say the various climates emits, right? So does not recognize water as a right water as a harmful gas which needs to be right curtailed because the utility of the water, right, is sorry, because the use of the water, one thing is not possible to curtail, right? Yes, we are trying to do it, you can say, otherwise also, right? The various governments and are running the public awareness campaigns, right? So that wastage of water should be avoided, and various NGOs are also running the public awareness campaigns, right? That water should not be wasted, right? And similarly, you can say there are the rain harvesting schemes also, right? Programs also there, right? So water tax is also there to discourage the consumers to use right lesser amount of water, right? Actually, I am answering this, right? I am speaking about this water because Mr. Raviraj has raised a question that water is also produced by the anthropogenic causes due to which the water vapor concentration in the atmosphere goes on increasing. That was the question which was raised by Raviraj, right? So I am replying that yes, anthropogenic, you can say, activities have a bearing on the extraction of water, right? Bearing on the, you can say, wastage of water, right? So that is why, right? So that leads to the, you can say, more evaporation of water, right? More evaporation of water would amount to the, you can say, concentration of more water vapor into the atmosphere. Yes, Mr. Raviraj is correct uh, up to this point, right? But water is such a basic necessity of life, right? So the use of which cannot be right strictly, you can say, uh, strictly discouraged, right? In that manner, that may harm the lives, right? That may affect the food production also, right? That may lead to the food insecurity also, right, in the country, right? And that may lead to the mass migration as well, right? And civil movements as well, right? So that is why, right, I was telling him that yes, various governments are doing at their, we can say, own end, right? Water taxes are being imposed to discourage the use of water. One point is that, and similarly, the you can say second thing is that, right? So public awareness campaigns are there, which are being run by the government and run by the various NGOs also, so that the use of the water may be discouraged. This is the next point, right? And next point is there that the various technologies are being developed, right, with the help of which the wastage of water, in particularly the, you can say, agriculture sector, may be reduced, right? Okay, so like you can say drip irrigation system, right, is one such system which prevents the wastage of water during the irrigation, right? Otherwise, our farmers were using the flood irrigation method, right? So now we are introducing the right drip irrigation method. So with the help of the drip irrigation method, right? So wastage of water would be reduced to a larger extent. So that is the point there, right? And similarly, the rain harvesting, right? You can say techniques have also been developed, right? So water storage, uh, right, is also being advised by the government today. So in various ways, right, the efforts are being done to control the, you can say that use of the water, right, so that water may not be used for the wasteful purposes. It should not be wasted at all. That is the point, right? And apart from that, yes, it cannot be made, right, a part of the greenhouse gases, right, which have been, you can say, there in the Kyoto Protocol, or similarly in the Paris climate, right, deal, like we take the carbon dioxide or other gases, right? Because the compulsory, right, the compulsory cut in the use of water, right, may lead to, right, catastrophic consequences on the life, or in this world, right? So it may have the political implications, economic implications, social implications, right? So that is why the use of water, if we want to curtail or discourage, right? So that should be with the participation of the people, right? So it cannot be strictly imposed like that. Okay, so that is the point. I think, Mr. Raviraj, it's clear to you. This was your question, I think. So now let me move ahead. What's the benefit of atmosphere, right? So first benefit of atmosphere, which is very much important, that weather phenomena exists due to the atmosphere, right? Weather phenomenon exists due to the atmosphere, right? No atmosphere, no weather phenomenon. That is the one point, due to the atmosphere. Okay, one point is that, which is very much important point, right? And second thing is that, right, atmosphere, okay, protects us from the harmful effects of ultraviolet rays, right? Ultraviolet rays of the sun, right? You know, the ultraviolet rays coming from the sun towards the earth, those are absorbed by the ozone in our stratosphere, right? So that is why this is the point, right? It protects us from that. Third is that atmosphere protects us. Atmosphere protects us from the, right, from the bombardment of, right, from the bombardment of, right, we can say meteorites, right? Meteorites means rock pieces which are coming from the space towards the earth due to the gravitation of the earth, right? So we can say meteorites. Okay, so that is there, right? Meteorites and other, right? You can say charged particles, meteorites, charged particles coming from the sun towards the earth, charged particles, etc. So this is the next point, that how atmosphere is beneficial and better for us, right? So that is also the important thing, right? So apart from that, right, we can say that, right? So atmosphere provides the greenhouse effect, right? Atmosphere provides the greenhouse effect, due to which the life, uh, greenhouse effect, due to which, right, due to which the earth remains warmer. Okay, earth remains warmer, right, during the nights also, warmer during the nights also, and during the nights also. Okay, and it has made possible, right, it has made possible, okay, the life on this planet, possible the life on this planet. So this is the next important thing, that what is the, right, this uh, you can say role of this, right? So apart from that, we can say that, right, it is important in distribution of, right, temperature throughout the globe, right, distribution of temperature throughout the globe. So these are some important implications or important benefits of the atmosphere, right? So there may be many other benefits, but for us, as far as this is concerned, only this part, I think, is sufficient for us to be discussed here, right? So that is the issue now. Okay, so now the next thing is that we know, right? We know that atmosphere, right? Atmosphere has weight, right? So it exerts pressure on the surface of the earth. It exerts pressure on the surface of the earth, right? Surface of the earth, right? So we can say the weight of the weight of an the weight of a column of air, right? Air over per square centimeter, right? Over per square centimeter surface area is known as the atmospheric weight, right? Is known as the atmospheric weight, right? So that is the point. Okay, so now the next thing is that, right, atmospheric weight is not similar all over the globe, right? So okay, which third point is there, Vicky? Which third point is there? Atmosphere protects us from the bombardment of meteorites, charged particles. This point. Okay. This point, Peter, I will repeat there, right? Right. So this point I am going to explain in the next lecture, right? In the same lecture today, means in the next, you can say, few slides, right? So I will explain that. Don't worry, right? Everything will be clear to you. Okay. So atmospheric weight, right? So now I'm telling you that atmospheric weight, right? Atmospheric weight is not sorry, atmospheric pressure बोलना था इसको, right? Known as atmospheric pressure. Okay, atmospheric pressure, right? So atmospheric pressure is not the same at all places on the globe, on the earth, we can say, all places on the earth, right? So it increases, right? It increases, we can say, at low-lying sites. It increases at low-lying sites, and it decreases at, right? And it decreases at the heights, right? At the heights, okay? At the heights, right? Means what is there? That atmospheric pressure decreases with increase in height, okay? Atmospheric pressure, right, decreases with increase in height, decreases with increase in height. So this is the point, okay? Decreases with the increase in height, I can say, okay? So now I'm moving on to the next slide, right? So I have told you that atmospheric pressure decreases with increase in the, you can say that altitude, right? So let's suppose this is the, okay, let's suppose this is the atmospheric pressure, okay? This is the atmospheric pressure, right? And I, let me take it that this green, sorry, this blue, you can say this arrow, that is, let's suppose the altitude. So this is the altitude here, let me take it, right? So this is the altitude, right? So the relationship is there, that with increase in altitude, right, the atmospheric pressure will fall, right? Why? Because, right, as you start moving upwards, okay, let me tell you that this is the upper limit of the atmosphere, right? This is the upper limit of the atmosphere, right? Let me take it, okay? Beyond this there is no atmosphere, beyond this there is vacuum, right, which is there in the space, right? And now let me take that, you can say this is the, right, sorry, now let me take it that this is the, we can say, surface of the earth, right, which runs like this. This is the surface of the earth, we can say, right? So this is the surface of the earth, which is like this. Okay, so now this is the upper limit, right? So we can say between this upper limit and the surface of the earth, there exists the atmosphere, right? There exists the gases, right? There exist the gases, particles, water vapor, right? So between these, right? So now let us see that, right? Let us see that the, you can say, the length of the column of air at this particular point, right? Let me mark this point as A, right? As A, right? So this length is, you can say the length of the column of air at this point is the largest length, right, as compared to other points, right? So let me take the point B here, right? B, okay? So the length of this column of air at this B point, right? So that is the smallest length because the point is at a height, okay? Let's suppose this is the Mount Everest, right? The point is at height. So now what is there? When the length of column of air decreases, right? So obviously the weight of air on per square centimeter area will also decrease. Okay. So if the weight decreases, then that means atmospheric pressure decreases. Okay. So therefore, this is to prove that, right? So atmospheric pressure decreases with increase in height. Okay. Atmospheric pressure decreases with increase in height. Is it clear to all? Geeta, is it clear to you? Okay. See, beta, if you will, right, if you will turn on your cameras, right, so that will be better for me to, right, easy for me to, you can say, teach you in that case, right? Let's suppose, right, Geeta's camera is, you can say, on here, right? So I was looking at Geeta, right, when I was explaining this point, right? So I thought that, you can see, Geeta may have some problem, right? So therefore, I asked it, right, to Geeta immediately, right? And you may be thinking that why sir is asking from Gita, right? Why not from us? है ना? Because Peter, your cameras are not on, right? Gita's camera is on. That is why it becomes easier for me, right? To, you can say, right? Uh, Note the face expression of the students while I am teaching, right? So that is why I'm telling you that this is the importance of, right, keeping the cameras on while taking the class. Okay. So now, so this point is clear to you that atmospheric pressure decreases with increase in height, right? So beta associated with this is a very important phenomena, very important point I can say, right? Right. So when you right go on hills, right, on hills at higher latitudes, sorry, at higher altitude, right, at higher altitude, right, what happens, right? So blood, right, start flowing, okay, start flowing, okay, from nose or the ears of individuals, right, nose or ears of individuals, okay. Some individuals may happen this problem, right? So this is a common thing, right? Because what is the problem here? Why does this happen, right? Because here here the problem is that, right, when you reach at a height, right, when you reach at a height, your body pressure remains same, constant, right? Internal pressure of your body, that remains constant, right? Internal pressure of body, right? So internal pressure of body, okay, does not change, that remains constant, okay, does not change. But, right, but the atmospheric pressure comes down, okay, but the atmospheric pressure comes down with increase in height, right? And therefore, the liquid start flowing from high pressure to low pressure, right? Therefore, the liquid start flowing from high to low pressure, okay? So the liquid start flowing from, okay, so the liquid start flowing from, okay, starts flowing from high to low pressure, okay, from high to low pressure, right? So now there are the outlets of the body, right? Nose, ear are the body's outlets, right? So now, right, internal pressure is high, external pressure is low. That is why the blood from your right body, right, starts flowing through your nose and through your ears, right? When you reach at the height, right? So this is due to the imbalance of temperature, right? Sorry, imbalance of your of internal pressure of your body and the atmospheric pressure outside. So this is the reason that why when you reach at the heights, right? So blood starts flowing outward from your nose and you can say ears, right? Right? Have you heard about this? That blood starts flowing out of ear or nose, right? So when we reach at the heights, right? So I think you may have heard about this. Okay. Uh, okay. So this is the reason behind that, right? Difference in this. Okay. So that is the point, right? Good. If you know this. So now the thing is that, right? Now let me tell you that the atmospheric pressure, right? Atmospheric pressure, right? At sea level is approximately, right? Average atmospheric pressure at sea level is approximately 1.03 kilogram, right, per centimeter square, right, per centimeter square, right? So that means, right, all of us, right, are having the weight of air on our shoulders, right? All of us are having the weight of air on our shoulders, right? But we don't feel that weight. Why? Because the internal pressure of body, right? And the external atmospheric pressure, right? Those are in balance, right? So when those, right, when that balance will be disturbed, then we will start feeling the weight, right? Or we will start feeling much lighter. So this is the point. Okay. So now the next thing which is there. Okay. So now the point is that okay. So when, right? So I have told you that at sea level on the surface, right? On the surface, the atmospheric pressure is, right, 1.03, right, kilogram, okay, per centimeter square. I have told this to you, this point to you. Okay. So previous slide. Yes, I'm showing you to the previous slide to you. Should I move further? Karthik, tell me. Karthik. Okay, okay. So now the next point, which I was telling you, that at sea level on the surface, the atmospheric pressure is this, right? So when we, right? So when we, you can say, when we reach upwards, sorry, when we move upwards, the atmospheric pressure starts on decreasing, right? When we move upwards, the atmospheric pressure, right, keeps on falling, right? Keeps on falling. So that's the point here, right? Falling, and at the top of atmosphere, right? At the top of atmosphere, right? It is reduced to, right? Or it is reduced to approximately, right? To approximately 1 upon, right, 10,000th part, right? 1 upon 10,000th part of the pressure at sea level. Okay, the pressure at sea level. Okay, so itna kam ho jayega pressure when you will when you will reach at the top of the atmosphere. That is the point there. Okay, so we can say this is the important point here, which was to be discussed today. Okay, so now the next important thing is now we are moving on to the layers of the atmosphere, right? Now we are moving on to the layers of the atmosphere, right? So let me draw that, right? Layers of the atmosphere. Let me draw that, okay? So let's suppose this is the one line which indicates the altitude. Altitude means height, right? This is the one line which indicates the altitude means height, right? In what? In kilometers, right? Height in kilometers. Let us take it, right? And this is the second line, right? Which is the horizontal line, right? The horizontal line, we can say, indicates the temperature, okay? Indicates the temperature. Let's suppose the temperature is in degree Celsius, right? So let us take it that temperature is in degree Celsius. So this is the thing there, right? Okay. So now let us mark some, okay, points here. Let's suppose this is 10 degree, this is 20 degree, right? This is 30 degree, okay? So this is 40 degree, that is there. This is 50 degree, okay? This is 60 degree, okay? This is 70 degree, right? This is 80 degree, sorry, 80 kilometers, sorry, I'm wrong. This is 80 kilometer, right? And let's suppose this is, now you can say here it is a, let's suppose 90 kilometer, and here it is 100 kilometer, and so on. Let's suppose this is the thing, right? This is the entire thing. Let us take it like this, okay? So this is the entire thing, right? So let us move it downwards for the sake of simplicity. So now, okay, let me mark it here, right? So this is 100, right? And this is, let's suppose you can say 90, right? And next it is 80. Next it is, we can say 70. Second, let me write it. This is 100. And now this is, we can say 90, okay? And this is 80, right? And this is 70. This is 60, okay? 60. This is 50. And this is 40, right? This is 30. 30, and this is 20, right? 20, and this is 10, right? So this is the height, or we can say the altitude, and here comes 0. Okay, this is the height. Now there is the point of, we can say, the temperature as well. Temperature as well, right? So let us take it that one is you can say this, right? 1, 2, 3, right? 4. Okay, this is there, this is there, this is there, this is there, right? So let's suppose this is the point, right? So now let me take it that the temperature which is there, okay, let me take it, the temperature which is there. Let us say that this temperature is a minus 120 degrees Celsius. Okay, I'm taking it minus, okay, 120 Celsius. Okay, so this is that temperature, right? And the temperature which is here, 1 second, and the temperature which is here, let me take this temperature as a minus, right, 100, 100 minus 100, right? And the temperature which is here, let me take it minus 80, okay, 80. And the temperature here, it is minus, okay, 6 and 0, 60. And the temperature which is here, it is minus 4 and 0, minus 40. And the temperature which is here, this is the minus 2 and 0, minus 20, okay? And this is 0, okay? And this is, you can say, plus 20, okay? Plus 20. And this temperature is, we can say, that is the plus 40, and so, right? Plus 20, and this can be taken as plus 40, and so on, okay? So this is how I have taken this temperature, right? So now the next important thing which is there. So I'm telling you that there are various layers, right? So one layer of atmosphere is formed approximately, right, is formed approximately at the 10 kilometer. One layer is formed there approximately, right, at a 10 kilometer height approximately. So one layer will be formed here, right? So one layer of atmosphere will be formed here, we can say, right? So it will go like this, right? Up, down, swinging. So it is there, right? And the second layer is formed at approximately, second layer goes approximately up to 50 kilometer height. And third layer goes approximately up to 80 or little more than 80 kilometer height, right? And next go on like this, okay? So this is the point, okay? So now the important point is that, right, in this first layer, let me take it now, right, or this. So now the point is that in this first layer, right, temperature range goes from, right, plus 20 degree up to, you can say, minus 50 degree. So the temperature range goes up to this point, we can say here, right? Between, you can say, 40 and 60 it will go. It will go up to this point, right? So then for a while, the temperature will become constant here, right? Constant here, no increase in temperature with increase in height. Okay, so then what will happen? Temperature will start increasing here, right? And temperature will reach up to the 0 degree, I think, right? Up to 0 degree, it reaches there, right? And then what will be there? Then again, the temperature will come constant for a while. Okay, it will come constant for a while. And then it will again start declining, right? Then it will again start declining and it will go up to, right, 100 minus 120 degrees Celsius, right? And then again the temperature will, you can say, become constant for a little, for a while, right? And then for some height, you can say, and then it will start, right, growing like this. फिर तो पता नहीं कहाँ चला जाता है. Okay, so this is, we can say, the various layers of the atmosphere. Now we will discuss these layers one by one. Okay, now we'll discuss about these layers one by one. Okay, so this is very much interesting, in fact, the topic, right? So no need to worry about this. Okay, so it will be very much clear to you, right? There is very important logic here, right? So now, beta, the main thing is that this layer which is at the bottom, this layer is known as the troposphere. Troposphere. Okay, one point is that, right? And this zone where the temperature becomes constant, that is called the tropopause. Okay, that is called the tropopause, right? And this area where the temperature again start increasing, this is called the stratosphere. Okay, stratosphere, right? And here again the temperature becomes constant. This is called the stratopause. Okay, stratopause, right? Stratopause, right? So then this entire part is known as the mesosphere, right? Mesosphere. And then the next part where it becomes constant, this is called mesopause, right? Mesopause, right? And then the next layer, right? This is ionosphere, thermosphere, right? Let me write here, thermosphere, ionosphere, right? ये layers आ जाती हैं. Okay, and then it slowly, right, ends up in the outer space, means merged into outer space. So this is the point, right? So now one thing, that average height of troposphere, right, temperature, average height of stratosphere, temperature, average height of mesosphere, temperature, right? These are important from your examination point of view. Okay, स्ट्रेटोस्फीयर में टेम्परेचर है क्यों हुआ, हाई क्यों हुआ सर? Yeah, I am telling you, right? Let me explain everything, right? So I will explain everything to you. Okay? Don't worry. So this is the point. First of all, is this clear to everybody? Have you you can say drawn this figure in your on your papers or not? Please tell me. Have you drawn this figure on your papers or not? Tanushri, Santosh, Dr. Santosh, Amarnath, right? So have you drawn it on your papers or not? Rest of the candidates, Navreet, Aman, Vicky, Gursimran, Anish, Sakshi, Pooja, Ayushi, right? Kusum and Malika Parian and Sakshi, etc., right? So whoever is there, tell me, have you drawn this image, and is it clear about this image? Uh, if you have any doubt about this image, please tell me. No, no, everybody has drawn this image. This is good. Okay, okay, right, very good, okay, very good. So please flow with me, right? So it will be easier for you to understand the whole story, right? Okay, but can't understand. Understand, right? I have not asked about whether you have understand or not, right? Because beta, whether you have understood or not. Because I'm yet going to explain, right? I have just run the image only, right? So from seeing the image only, how can you understand this, right? So I'm moving further. Okay. So, right, my question was only that have you drawn this image or not? Right. So understanding, so obviously, right, till today, is there any doubt of you which I have left, you can say, right, unexplained, right? So that is why, right, this is very important phenomena, and I will discuss it in very much detail. Don't worry, right? So everything will be clear to you. Don't worry, please, right? So let me explain now troposphere first. Okay. So troposphere. Okay. So we are discussing about the troposphere now. What is this? You can say troposphere. First of all, this point is important. Okay. So one thing is that, right, here it is important to note that one thing is that troposphere, okay, troposphere is the lowest layer in Earth's, right, lowest layer of Earth's atmosphere. One point is that lowest layer of Earth's atmosphere. This is the one point. Okay, lowest layer of Earth's atmosphere. So this is the one point which is very much important point, right? Lowest layer. Okay. So now the next thing is that the the average height, right? Average height of troposphere, right? Average height of troposphere is is 10 kilometer from the surface of the earth, right? Is 10 kilometer from the surface of the earth. Okay, from the surface of the earth, right? Now here it is important to know again that that 2 points are there. Okay, so one is that height of right, height of troposphere. Okay, height of troposphere varies with change in latitude. Okay, with change in latitude. One point is this, right? And the second point is that height of a troposphere, right? Height of troposphere. Okay, changes with, okay, changes or varies with changes with change in season, right? With change in season, right? So these are the two important points. Please note these points, right? One point is that height of the troposphere, right, varies with the latitude. Second is height of troposphere varies with change in season, right? So now let me tell you, let me explain these two reasons, right? That why height of troposphere varies with change in latitude. Okay, so so I'm telling you that let's suppose this is the surface of the earth, right? And this is the, we can say, right, this is the equatorial line. Let me take it, right? This is the equatorial line. Equatorial line. Okay, this is the equatorial line, which we say is the 0 degree line. Okay, this is the equatorial line, 0 degree line. And this is, let's suppose, the polar line. This is the North Pole, right? And here is, let's suppose, the South Pole. Okay, here is the South Pole. This point is, right? And these lines, right, mark the, you can say, height of this, you can say, troposphere, right? These line mark those. And this is the beta 90 degree line, you know, Okay, 90-degree line north. North means north pole है यहाँ पर, right? And this line indicates the again 90-degree line south, because यहाँ पर south pole है, हम इसको ये मान लेते हैं, right? This is again the 90-degree south line. Okay, so now about the height of troposphere, right? The point, that is the height of troposphere, right? So it is like this. It goes like this, right? It goes like this, right? So we can say that height of troposphere, okay, height of troposphere, okay, is least on the poles, right? Is least on the poles, right? That is only 6 kilometer high, right? That is only 6 kilometer, and it is the highest at the equator. Okay, it is the highest at the equator. That is, we can say, that is 16 kilometer. That is 16 kilometer, right? And the average becomes 10 kilometer. So this point is important. Okay, please bear this in mind, that the height of troposphere increases from poles towards equator and decreases from equator towards poles, right? So it is maximum at the equator and it is minimum at the poles. Okay, at equator it is 16 kilometer, at poles it comes down to only 6 kilometer. Why this phenomena exists, right? The reason behind the existence of this phenomena is that there is a more warmth on the, we can say, equator, right? So there is high temperature, more warmth on the equator. Okay, why does this phenomena occur, right? This phenomena occurs because there is a more warmth on the equator. Please bear this in mind. Okay, more warmth means high temperature, right, on the equator. On the equator, all right, more warmth on the equator. So more warmth means, right, the air expands, right? The air expands, right, horizontally also and vertically also, right? The air expands vertically also, right? So when the air expands vertically, then the, you can say, the right, so air goes upwards vertically, right? So that is why the line of the troposphere, right, goes upward. Okay, the upper limit of the troposphere rises, right? And at the poles, there is the low temperature, right? Low temperature, approximately 0 degree temperature. So due to that low temperature at the poles, right? So you can say the you can say air contracts, right? So we can say if the contraction will take place, right? So then the horizontal contraction also and vertical contraction also will take place, right? So due to that vertical contraction, the thickness decreases. Okay, so beta, this is the reason, right? Why does this? Because of the temperature difference at poles and at the equator, right? So temperature remains high, right, higher at the equator as compared to that at the poles, right? Due to the higher temperature at the equator, right? Vertical, vertical as well as the horizontal expansion of air takes place, and due to the horizontal expansion of air, right? So troposphere has the, you can say, higher upward limit as compared with the poles. Okay, so this is the point. This is the phenomena, right? So now I am moving on to the next point, onto the next phenomena now. Okay, so be concentrated and be fully focused beta here, right? So that will be more beneficial for you, right? So if you remain fully focused at this here, right? If you flow with me, height of troposphere changes with change in season. That is true, because in summer season, right? In summer season, the height of troposphere would increase, right? Height of troposphere would increase, okay, would increase. And in the winter season, right? In the winter season, the height of troposphere would decrease, right? The height of troposphere would decrease. The same phenomena, that is the change in temperature, okay? Troposphere would decrease. So the same phenomena, change in temperature takes place, okay? So this is the point. All right. So this is what I mean to say that both the things, right, which I am telling you that at equator the height is more, and in summer the height is more. Both the things are associated with the temperature, right? So high temperature. So is this point clear to everybody? Please tell me. Jaldi, jaldi. Right? Right? Hurry up, please. Hurry up. Okay. So please tell me. Right? So, right. So we need to study the things, right? We don't need to only read the things or learn the things only, right? So that is why you should understand every concept, everything, right? So if there is anybody who to whom it is not clear, right? So those should raise their doubt. Okay, 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 okay. So what about others way? There are many students. Ayushman Bajpai is there. Okay, please explain the air extends vertically also point. Okay. Okay, I am explaining. What's the meaning of convectional current, sir? Convectional current is a thing, right? Separate thing. We will discuss those also. Okay. So don't worry, right? I will not anything un you can say, right? Convectional currents of air, right? So which move, you can say, right, horizontally from one place to another place, right? Rest of the things I will explain you, okay, in detail, right? So when we will come at that point, so far you please keep only this thing in mind, okay? So not an issue. Okay, so please have a look on this and tell me, right, if there is any question or any doubt to ask. So that's the point. So, right, for whom it is possible, kindly, okay, keep your cameras on. For those who can afford to keep their cameras on, they should please, at least, right? So if anybody has some particular problem that it's not possible for him or her to keep the camera on, then it's a different thing, okay? So now the point. Okay, so some of the students are asking that please once more, right? Let me explain once more. Okay, so once more is that, Peter, let's suppose this is a substance which is lying here. Okay, this is a substance which is lying here. Okay, substance, right? So, and when you heat up this particular substance, right? So this substance will start expanding, right? When you will heat up, this substance will start expanding. Is it now? Is it? This substance will start expanding, right? Melting, right? Meltdown will take place, will start expanding, right? And in which direction will it expand, right? So wherever it will find the way, right? It will start moving in that direction, right? So we can say that, right? So this expansion may be uh, in this side also, right? This expansion may be in this side also. This expansion may be in this side also. This expansion may be in this side also. This expansion may be this side also. This expansion may be this side also, right? So it means the expansion will take place horizontally as well as vertically. Okay, so vertical expansion भी हो सकती है और हॉरिजॉन्टल एक्सपेंशन भी हो सकती है. Do you agree with me or not? Do you agree? Okay, agree. ठीक है. So beta, that is why, right? So when the vertical expansion will take place, then what will happen, right? So this layer will reach at this point, right? Due to the vertical expansion, right? So it means the height has increased. Okay, so this is the only reason that why the troposphere sphere, right, has more length, has more height, right? Upper limit of troposphere has more height at the equator than at the poles. Okay, so this is what I was telling you. Okay, so I think now there were two persons' questions. One is that Amarnath, and second was Asika, right? So got it, got it. Okay, Amarnath, you didn't tell me that have you got it or not. Okay, so now now I am moving further, right? So now let us discuss that, right? What is the importance of troposphere, right? What is the importance of troposphere, or what is the role of troposphere? Now we are discussing this, right? Importance of troposphere, or what is the role of troposphere? Okay, so one important point is that about the importance or role of the troposphere, I would tell you that okay, one important point is there. You can say, right? So uh, almost all weather phenomena, right? Almost all weather phenomena occurs in this layer of atmosphere. In this layer of atmosphere, right? In this layer of atmosphere, almost all weather phenomena occur in this layer of atmosphere. Okay, so now this is the point, right? That why does this phenomena occurs in this layer? Okay, occur in this layer. Can anybody explain, please? Can anybody tell, please? Please. Okay, can anybody tell, please? Tanushri, here I have joined from this number. The device was not working. Okay, Tanushri, no problem, right? It's not problem. Okay. So one point is that almost all weather phenomena occurs in the lower layer of in this layer of atmosphere. Okay. So what's the reason? Okay, one response which I have got that it is closest to the surface. Okay, one response is that to the surface. One response is that, right? So any other response, please tell me. Right? Any other student to the surface? Any other student, please tell me. Right? Any guess? Anything? All right. So many. Right? You can say atmospheric pressure is high. Okay. So second point is that atmospheric pressure is high here. Okay. So this is the second question, which is there. Okay. Yes, Nishank, I am giving you time. Just 1 second. Energy is trapped in this layer. Okay. More energy is trapped in this layer. This is the next point. More energy is trapped in this layer. Okay. So next point. Next anything. Okay. Till then you think, let me give a chance to Nishank to speak. Nishank, you can speak now.
So this is because of the reason that water particles and most of the water vapors and other dust particles etc. are present in this particular layer of the atmosphere, which is troposphere, and this causes sir मतलब कि cloud वगैरह जो बनते हैं वो यहीं बनते हैं फिर.
Water vapor. Okay. So water vapor and the dust particles exist here. Okay. So this is the next point, right? So any other point if anybody wants to say? Okay, so don't hesitate. Okay, so अपनी अपनी जो भी opinion है, you should give openly, right? So now, if I conclude it, right? So there are the reasons, right? One reason is that, uh, right, almost, almost, right, entire amount of or volume of, we can say, entire volume of almost लिखा मैंने volume of water vapor exists in this region, right? Water vapor exists here. So this is the one point, right? Water vapor exists here. So this is one important point. Okay. And right, water vapor exists here, right? Yesterday I told you that water vapor has a very important bearing on the weather phenomena. Yesterday I told you that, right? Water vapor has a very important bearing, okay, has a very important bearing on weather phenomena.
Yes, sir. Cloud formation.
Yes, bearing on weather phenomena, okay, phenomena, right? Phenomena. So that is one important point. Okay. So that is one important. Because why water vapor? Because you can say, right? So if there is water vapor, there will be the cloud formation, right? If there is water vapor, there will be the cloud formation will be there. Okay, more cloud formation, right? And because the source of water is lying on the, we can say, earth, right? That is the oceans, other water bodies, vegetation also, right? So therefore, whatever the water evaporates, right? So that remains in, you can say, abundant quantity in the lower layer of atmosphere, that is the troposphere. Okay, so this is the point, right? And the next thing is that for the condensation of water vapor, right? Condensation of water vapor. Condensation means when gas turns into liquid, right? So that process is called the condensation, right? So for condensation of water vapor, what is required? I told you yesterday that some nucleus,
Nuclei.
right? Some nucleus is required, right? And that, right, and the dust particles which are in very you can say high quantity, right, uh, in the lower layer of the atmosphere because of the gravitational force of the earth, because उनका weight ज़्यादा रहता है. So dust particles, right, are, you can say, spread in the lower layer of atmosphere in very high quantity, right? So therefore, the nucleus are provided by those dust particles, right? And the condensation takes place on that surface, right? And which leads to formation of clouds, right? And therefore, the rain falls, right? So this is the reason that, right, that almost entire weather phenomena occurs, we can say, in this region only, right? In this region of the, we can say, troposphere only, right? Okay, so that's the point. Okay, so now the next thing is that, right? So the next point is that, right? One point was also raised by Nishank, that because the it is, you can say, written here also, that cloud formation takes place here, right? Cloud formation mainly takes place in troposphere, in troposphere, okay, in troposphere. Okay, so beta basically क्या होता है? Let me tell you little about the clouds also, right? About the clouds also, right? Right. So you can say, right. So let me tell you about the that you can say, okay. So clouds की formation कैसे होती है, right? As far as the sorry, clouds की formation, clouds के बारे में, right? Clouds are formed. Clouds are found in. Okay, clouds are found in. are found in the three layers of atmosphere. Okay. Okay. Right. So clouds are found in three layers mainly of atmosphere. Okay. Are found in three layers of atmosphere. Right. So let me tell you about the three layers of atmosphere. Right. So let me move on to the next, the previous slide. Okay. The layers where the clouds are found, right? So one layer is this layer, mesosphere, second is stratosphere, and third is the troposphere. Okay? Clouds are formed in these layers. Okay. So the clouds that are found in the mesosphere, okay, so those clouds are known as the Noctilucent clouds, right? Those clouds are known as Noctilucent clouds, right? Clouds, right? Nocti means night, lucent means shine. Those clouds that shine at nights, right? But these clouds has nothing to do with the rainfall, okay? Because in mesosphere, a very, very rare amount of the water vapor is found, right? So because of the low temperature in mesosphere, that water vapor also, you can say, condense, right? And due to that, these noctilucent clouds are formed in this zone. Okay. So nocti means night, lucent means bright. Okay. So, and the next thing is that in this zone, stratosphere, right, nacreous clouds are found. Nacreous clouds are formed. Okay. Nacreous clouds, these clouds are known as the mother of pearls also, because these clouds look colorful clouds like the pearls, right? So that is why it got the name nacreous clouds. Okay. Nacreous clouds. Okay. So these are the feather like, you can say, right? Feather like clouds out there, right? And but the main clouds are found in this zone. Okay. Main clouds, right, which affect the weather phenomena, those clouds are found in this zone. Okay. So please bear this in mind that clouds are found in three zones. Okay. So one is the mesosphere zone where the clouds are found, right? One is the mesosphere where the clouds are found, right? Clouds in mesosphere are called noctilucent clouds. Okay, noctilucent clouds. Okay, so the next thing is that clouds in stratosphere, right? Clouds in stratosphere, those are called nacreous clouds. Nacreous clouds, right? And nacreous clouds are known as mother of pearls also, right? Nacreous clouds. These are known as mother of pearls as well. Okay, let me write it here. So these clouds are known as mother of pearls. Okay, mother of pearls also. So please bear this in mind. Okay. So the next category of clouds, right? Those are found in the troposphere. Okay, troposphere. Those are found in the troposphere. Right. So now the next thing is better. The classification of clouds in troposphere, right, can be done on two bases, right? Can be done on two bases, right? One base, that is the height, right? So one classification can go on the basis of the height of the cloud, right? That we can say at what height the clouds are formed. One classification is that, and second classification is their form, right? Their appearance, we can say their appearance. Okay, so second classification is on the basis of that. That is their appearance, right? So we can say there are two types of two classifications of the clouds can be made, right? So one classification is there on the basis of their height, right? That way they're formed, and second classification is there on the basis of their appearance, right? So as far as the height is concerned, right, So there can be two types of clouds which are very, which are of very much height, which are at very much height, which are formed at very much height. So these are called the cirrus clouds, right? And second is the clouds of medium height. Those are called the alto, right? So आपने मारुति की alto car देखी होगी, right? So that car was made by the medium class, right? So they got that name from here. Alto means medium, right? So beta, this is there, right? So there are two categories on the basis of the height, right? One category is clouds which are at very much height, you can say, exist, right? Which exist at which exist very high, right? And the second type of the clouds, that is the alto, which are the medium height, right? Okay, so clouds of great height and clouds of medium height. So these are the two types of clouds. Okay, clouds of great height, and second is clouds of medium height. Okay, second is clouds of medium height. So the clouds of medium height are called the alto clouds. Okay, so these are the two, you can say, right, medium heights. So these are the two categories, right? And now next to this, right, there is the classification of clouds, okay, on the basis of their appearance, right? So as far as the appearance is concerned, right? So as far as the appearance is concerned, right? So some clouds like look, you can say, like a strata. Strata means like a sheet, right? Spread on something, right? So that is called the stratus, right? Stratus clouds, right? Stratus means in the form of a sheet, right? Spread like a sheet. Okay, so spread like a sheet. Those are called the stratus clouds, right? Spread like a sheet, like a sheet. Okay, so those are called the, you can say, stratus clouds, right? And the second type of clouds are, right, you can say bumpy clouds, right? Bumpy clouds, right? So means cumulus clouds, right? Which are in the shape of a cauliflower, right? Which are in the
सर ये
shape.
आप अपीयरेंस के सर ये आप
Hello,
अपीयरेंस के बेसिस पे बता
hello,
रहे हैं
hello. So which are in the shape of a cauliflower, we can say, right? So these are the two forms of clouds, right? Let me, Peter, let me explain to you. I think Geeta is not getting me properly, right? So what I am trying to tell. So beta, one is this form of cloud, right? So which is spread in the form of a sheet there. Okay, this, let's suppose, right? This you can say, right? So let me again take it that, right? It is like this. It goes like this in the form of a sheet in the, you can say, uh, in the above it, upper atmosphere, right? In the atmosphere. So that is there. Okay. And the second thing is that the clouds which are in the form of a right heap like this, right? Like this, you will see, right? The clouds are formed like this. Now, right? You might have seen such type of clouds in the monsoon time, now. Okay, right? Like the cauliflower, you can say, right? Let me show it to you, right? Let me show it to you. Give me just 1 minute, right? So I'm showing it to you so that it should be clear to you. Okay. So yes, so just 1 second. So just see, I'm just bringing it here. Sorry. Sorry. Okay. So, so now I'm sharing this with you, my desktop. Are you seeing this? Are you seeing this? These clouds are stratus clouds. Okay. Have you seen such type of clouds now in the sky? Okay. So now let me take another also, right? Another also, so that this may be clear to you, right? So these are the clouds of this type, Peter, in the form of this heap. Okay. Have you seen this type of clouds also? Or not? Seen or not? Please tell me. Seen or not? Is there any person who has not seen such type of clouds in the sky? Please tell me. Okay. So these type of clouds, okay, clear na? These types of clouds. You may have seen these clouds, okay. So everybody knows about this, okay. Harshita, Renmi, okay, Asika, seen, okay, good, beta, good. Okay. Yes, these are on the basis of appearance, which I am telling you that there are these types of clouds as well. Okay, so let me now move on to that. Right, so these are the two types of clouds, stratus clouds and cumulus clouds. Right, so we can say that these cumulus clouds, right, are like a heap, right, like a heap or like a cauliflower. Okay, so these are the clouds of that type, like a cauliflower. Okay, right. So now, beta, what is there? What is next now? Right, I'm coming to that point. Right, so what is next now? Next is the combination of these, right? So the stratus clouds, which are formed at a great height, those stratus clouds are called cirrostratus clouds, right? Those stratus clouds are called cirrostratus clouds. Okay, cirrostratus. Okay, so these are the clouds which are formed at, which are of stratus type and are formed at great height. So those clouds are known as the cirrostratus clouds. Okay, I think it's clear to you. And these clouds are called, we can say, right, alto stratus clouds, alto stratus clouds. Okay, these are called alto stratus clouds. Okay, alto stratus clouds. So this is there. And the next, yes, I'm telling you, beta. So next is the right, this type of clouds. These are called the cirrocumulus clouds, right? Cirrocumulus clouds. Okay, cirrocumulus clouds. So these are those type of clouds, right? Cirrocumulus, the combination of these, and these are the alto cumulus clouds, right? Alto cumulus clouds. Okay, alto cumulus clouds. Right? Okay, and now the next thing is, beta. Now the important point here is that right, uh, none of these clouds bear the rain. Okay, none of these clouds bear the rain. ये आते हैं चले जाते हैं. Okay, none of these clouds bear the rain. Right, and there is a special category of clouds which bear the rain. Those are called the Nimbus clouds, right? Nimbus clouds are those clouds which bear the rain, right? If such a type of a question is asked in the examination, right, the name of the cloud where the term nimbo or nimbus is used, right? So that will be the rain-bearing cloud, right? Rain-bearing clouds, right? So we can say on this basis, right? Nimbus clouds, right? Attached with the appearance. So those can be the nimbostratus or nimbocumulus clouds, right? So nimbus clouds, right? Along with their that you can say appearance, right? So those can be called nimbostratus, right? Or right nimbocumulus clouds, right? Nimbocumulus clouds. Okay, so these are the clouds which bear the rain, right? So please bear it in mind. Nimbus clouds are the only clouds which bring rain, right? Other clouds don't bring rain. Okay, so this is the point. So I have told you about the clouds as well. So all these clouds are formed in the troposphere. Okay, so all these clouds are formed in the troposphere. Please remember. Okay, all these clouds are formed in the troposphere. It means the rain-bearing clouds exist in troposphere only. Beyond the troposphere, there is no rain-bearing cloud. Okay, so please remember this, what I am telling you. Okay, this point is very much important point for examination also, right? So please tell me, is it clear to you up to this point to everybody? Please tell me, okay? So with a thunderstorm, lightning, that is a separate phenomena we will discuss separately, right? Here we are talking about only and only the types of clouds, right? Because it was there in this troposphere, that is why I start discussion on that, right? So if we start a discussion on that thing, that lightning and thundering, what is the reason behind that, right? So then we will derail, right? Then we will be derailed, and that will be problem. Okay, so that's why let me focus on this only, right? So I hope it is clear to everybody. So with this hope, now I am moving, you can say further, right? With this hope, I am moving further now. Okay. So now there is, you can say that, okay. So in, so this is clear to you now. So beta, as we have seen in the case of this troposphere, right, that curve goes like this, right? In terms of the altitude, this side we were taking the altitude, you must be remembering, right? And right altitude, okay? And this side we were taking the temperature. So I told you that curve goes on like this, right? Fall, right? So what does this mean, right? What does this mean? Okay, electric. Okay, no problem, beta. So what does this mean? Now the thing is that, right, in troposphere, in troposphere, okay, in troposphere, sorry, right? So temperature falls with increase in height, right? Temperature falls with increase in height, okay, with increase in height. Yes, right? So the average rate at which the temperature falls with increase in height, right? Average rate at which the temperature falls with increase in height, right? Falls with increase in height, with increase in height in troposphere, okay? In troposphere. पवन कुमार बेटा प्लीज ऐसा ना करो यहाँ, ओके ओके adiabatic, okay. No beta, the average temperature at which the the average rate at which the temperature falls with increase in height in troposphere, right, is called the normal lapse rate, okay, is called the normal lapse rate, okay, that is known as the normal lapse rate. Okay, so normal lapse rate, right? Fall in temperature with increase in height in troposphere, right? The degree at which the temperature falls with increase in height, that is called the normal lapse rate, right? And this normal lapse rate in troposphere is 6.4 degrees Celsius per kilometer. Okay, 6.4 degrees Celsius per kilometer. So the fall in temperature. Pawan Kumar, please, 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 Pawan, please. Pawan, please remove these arrows which you are drawing here. Pawan, okay, I'm removing you from class. Okay, so beta, I was telling you that in troposphere, right, in troposphere, the rate of fall in temperature, okay, the rate of fall in temperature with increase in height, right, is called the normal lapse rate, right? The degree at which it falls, it called the normal lapse rate, okay, lapse rate, right? And the normal lapse rate is at 6.4 degrees Celsius per kilometer. Okay, this is at 6.4 degrees Celsius per kilometer. So please bear this in mind that temperature falls with increase in height, and this fall in temperature is equal to this. Okay, why this fall in temperature in troposphere, right? Why this fall in temperature, right, in troposphere? Because the right because the most of the water vapor, right, most of the water vapor, right, and greenhouse gases, right, most of the water vapor and greenhouse gases, right, occur you can say in the occur in the lower layer, right, in the lower layer, that means near the surface, okay, near the surface. So as we move upwards, right, as we move upwards, right, the water vapor and the concentration of greenhouse gases decreases, right? Greenhouse gases decreases, right? And therefore, there is less warming effect, right? Therefore, there is less warming effect. Therefore, there is less warming effect, okay, in the, we can say, upper parts of the atmosphere, right? So this is the reason that why temperature falls with increase in height in the troposphere. I hope it is clear to everybody now, right? So now the next thing is that, right, how do we come to know about the weather phenomena in the troposphere, right? So is this still tropopause? I'm not talking about tropopause now, right? So we are discussing about this troposphere only, okay? So, so now the next point is that how do we come to know about the this weather phenomena in the upper layers, right? So we come to know about the weather phenomena in the upper layers, right, with the help of the weather balloons, right? Weather balloons and rockets, right? with the help of the weather balloons and rockets, we come to know about this thing. Okay, this thing. So now the point is that, okay, so that's there. So now the next thing is that troposphere is characterized by, right? Troposphere is characterized by, right? Troposphere is characterized by the, okay, characterize bit of weather balloons are, you can say, right? You can say uh, left there in the upper layers of atmosphere, right, to know the weather, right? So we will discuss about this technology further, right, in our science and technology. So troposphere is characterized by the, right, characterized by the turbulence of winds, right? More turbulence of winds, you can say. More turbulence of winds, right? More turbulence of winds. Troposphere is characterized by that. Okay, and first of all, this characterized by more turbulence of winds, right? Turbulence of winds means, right? So winds move in like this, right? We can say swirling winds, you can say, right? Swirling winds, you can say in this form, right? So more turbulence, the more problem will be there. And the second thing is that, we can say, right, towards the, right, towards the upper limit of troposphere, right, towards the upper limit of troposphere, right, towards the upper limit of troposphere, right? So very fast winds, okay, very fast winds blow, right, very fast winds blow, right, in the horizontal, right, in the horizontal direction, right, in the horizontal direction, right, either from, right, east to west, east to west, west to east, okay, east to west, west to east, okay, or from pole to pole, right? So such type of winds blow there, okay, and these winds are called the jet streams, okay, these winds are called jet streams. In winds को हम jet streams कहते हैं. So please bear this in mind that jet streams are very fast flowing winds, right, which occur in the troposphere, right, which occur in the troposphere, right? So please bear these 2 points in mind. Jet streams are fast flowing winds. Pehli, right, first thing is that jet streams are fast blowing winds, okay, fast blowing winds. And the second thing is that occur in troposphere, right, occur in troposphere. Troposphere also in the upper limit, right, in the upper part of the troposphere. Okay, so this phenomena, please bear in mind, in the upper part of the troposphere. Okay, so is it clear up to this point? If anybody has any doubt, please tell me. Please tell me. Right, so swirling winds are called the jet streams, right, which are running at very fast speed. So those are called the jet streams. Okay, so now please tell me, any problem to anybody? Have you understood it or not? Hurry up, please, hurry up. Understood, okay. Okay, understood, okay. Santosh, Amarnath, Asika, Harshita, Akanksha, Asha, Abro, Bhavesh, Geeta, and so many persons are there, right? So please tell me. Understood, understood, understood. Okay, okay. So if there is no question before me, right? So let me take it that everybody has understood up to this point. Okay, what I have taught so far. Okay. So the next thing is that beta. What is the importance of this jet stream now, right? What is the importance of this jet streams now, right? Due to this, you can say this phenomena of jet streams, this phenomena of jet streams, okay, of jet streams is very much we can say beneficial, very much beneficial for, right, beneficial for, you can say, right, for aircrafts, right, aircraft companies or for aircraft, right, because if the aircrafts, if the right aircraft, uh, right, fly along with the direction of, along with the direction of the jet stream, right? So jet stream, right? So it will save fuel, right? It will save, we can say, fuel and time, right, of travel, fuel and time of travel also. So that's why, right, if the planes, right, fly in the direction of the jet streams, then it becomes useful for the aircraft, yes, because it will consume less energy and it will take less time, right, to reach at the point of destination. So this point is very much important here. So is it clear up to this point? I am moving further now. Okay. So now the next point where I am moving. Okay. Right. Clear now. Clear. Okay. So now beta, next point. That is the stratosphere which I am going to discuss with you. Right. Stratosphere. Okay. Stratosphere. Now beta, after the right, you can say a transition zone between the troposphere and stratosphere is called the tropopause, right? A transition zone between the troposphere and the stratosphere is called the tropopause, right? And in tropopause, the pause means that fall in temperature with increase in height stops there, and that is why that is called pause, right? Pause, right? So it means what is stratosphere? It is a transition zone, right? It is a tropopause, right? Tropopause is a transition between troposphere and stratosphere. Okay, troposphere and stratosphere. All right, so that is the point, right? So beyond this, what starts, right? Beyond this starts the stratosphere, right? So beyond tropopause, okay, tropopause starts the stratosphere, okay, starts the stratosphere. Beyond tropopause starts the this stratosphere, right? And the as far as the stratosphere is concerned, right? So there are three important characteristics of the stratosphere. One important characteristic is that it is very calm layer of atmosphere. It is very calm layer of atmosphere. Okay, very calm layer of atmosphere. One point is that. Okay, so it extends from, right, it extends from the upper boundary of, okay, it extends from the upper boundary of tropopause, right, tropopause to the, okay, tropopause, sorry, to the up to we can say 50 kilometer of height, okay, up to approximately 50 kilometer of Okay, this may increase, decrease, right? 50 kilometer of height, right? And yes, Nishank, I'm allowing you to speak. Just 1 second. Yes, you can speak now.
So what is the reason that the temperature in the tropopause or in any of the pause remains constant?
Yes, because this is basically a transition zone, right? Because when something, right, was you can say constantly decreasing, right, right, and then it start increasing there, right? So we can say little bit there is a transition zone, right? So where the temperature does not fall beyond that, right? It means the fall in the temperature stops there, right? So we can say it's not possible, right? Due to the concentration of the gases or due to the characteristics of the lower layer, right? Which are you can say existing, right? And some characteristics of the you can say upper layer also, right? The mixture of the characteristics of the two layers, right? So you can say that leads to the cancellation of the effect of rise or fall.
Okay sir, got it. मतलब sir abrupt transition नहीं होता.
Yes. Abrupt नहीं होती, right?
Okay sir, got it.
Okay. So now, beta, this is the point, right? So we are moving next. So it is very calm layer of atmosphere. It extends from upper boundary of tropopause up to 50 kilometer of the height, right? And you can say, right? So winds, strong winds blow, but there is no turbulence, right? So strong winds blow here, okay? Strong winds blow here, blow in, we can say, right, in horizontal, right? Strong winds blow here horizontally, we can say horizontally, right? But there is no turbulence. But there is no turbulence, right? So turbulence नहीं है, but strong winds horizontally blow करती हैं. There is no turbulence, right? Turbulence. And right, particularly in the lower layer of stratosphere we are talking about, and therefore this, right, lower part of a stratosphere, this lower part of stratosphere, okay, is considered very much important, okay, is considered very much important for the jets to fly, right? For the jets to fly, okay, for the jets to fly, because there is no turbulence, right? Only horizontal flow of winds is there. So that's why this is an ideal, right, height for the jets to fly, right? Ideal height for the jets to fly. So that's why this is a very important thing here, okay? So this is there, okay? So now we can say the next thing is that right, the amount of water vapor falls in this layer, right? Amount of water vapor becomes very less, right? Amount of water vapor becomes very less, okay? Becomes very less in this layer, very less here, right? And that is why, right, very less here we can see, right? So that is why, right, you can say, though clouds are formed, but those are not like the clouds which are formed in the, you can say, lower layer of atmosphere, that is the troposphere, right? So clouds, right, stratospheric clouds are called nacreous clouds, as I have told you earlier, as called nacreous clouds, right? Nacreous clouds. So we have discussed about this also, are called nacreous clouds. Okay, so this is there, right? So now the next point is that uh, let us discuss about the one more important bearing of the stratosphere, right? What is turbulence? Turbulence is the horizontal and vertical, right, movement of the air. Means vertical movement of the air, up and down, up and down, up and down. That is called the turbulence. Okay. So now the point is that, next point is that, right? So stratosphere is considered, right? Stratosphere is considered a, right, very much important layer of atmosphere, layer of atmosphere, because a very thin layer of ozone, right, very thin layer of ozone in stratosphere, right, in stratosphere, okay, protects us from the harmful effect of ultraviolet rays of the sun, right, from the harmful rays of harmful effect of ultraviolet rays of the sun, okay, rays of the sun, right? So if this layer would not be there, right, then the ultraviolet rays would not be stopped there on the way, right, would not be stopped there on the way, and those would reach at the surface of the earth, right, and those would cause us a number of problems like skin cancer, right, a problem of this lungs problem, asthma problem, bronchitis problem, right, and those will harm the vegetation on the earth also, right? Okay, okay, I'm just showing Bhavesh, please take it. Done? Bhavesh, tell me, is it done? Okay, done. Okay, right, right, okay. So now the point is that, right, stratosphere is considered a very much important layer of atmosphere because a very thin layer of ozone in stratosphere protects us from the harmful effects of UV rays of the sun, ultraviolet rays of the sun, right? And beta, now the point is that why? Because ozone, which is called O3, right, absorbs solar radiation, right? Absorbs solar radiation means ultraviolet radiation, right? Absorbs ultraviolet radiation, okay, coming from the sun, all right? And therefore, okay, therefore, temperature, okay, therefore, temperature in stratosphere, okay, temperature in stratosphere increases with increase in height, right? Because more and more sun energy will be absorbed by this uh, stratosphere due to the prevalence of the ozone there, right? Therefore, the temperature rises with increase in, you can say, height, right? Temperature rises with increase in height there. Amarnath, what is this 11 beta? I don't understand. What do you mean by 11? Okay, increases with increase in height. So beta, this is the point, right? So why temperature in stratosphere increases? Okay, so please bear this in mind. So clear, why is temperature in troposphere falls? I have told you. Why temperature in stratosphere increases? I have told you that also. Okay, 2 points are clear now up to this point. Okay, so now beta, let me move ahead, right? We were talking about the ozone, that ozone absorbs the ultraviolet radiation. So now there are two things, beta. Ozone, as far as the ozone is concerned, right? Ozone is concerned. Ozone is a gas, right? O3, which means, right? So as far as the ozone is concerned, ozone is good as far as bad, right? Ozone is good as far as bad. Good and bad also, right? Good and bad also, right? So how we can say that ozone is bad, right? So here very important point is that when ozone exists in the troposphere, then it is bad, right? And when ozone is there in the stratosphere, then it is the lifesaver because it protects us from the ultraviolet radiation of the sun. Okay, so please bear this in mind, right? Ozone, right? So when it is there, okay, ozone, when it is in the, right, when it is in troposphere, it is bad. It is bad, right? And when it is in, okay, when it is in stratosphere, okay, stratosphere, it's good. It's good, right? So we can say that ozone is good as well as bad, right? So when ozone is in stratosphere, it is good. I have already told you that because the concentration of ozone in the stratosphere, right, protects us from the harmful effects of the ultraviolet radiation, which is coming from the sun, right? So in the absence of the ozone there in the stratosphere, right, the entire ultraviolet radiation would be received on the surface of the earth, and that would cause, right, various damages to the life as well as to the other vegetation as well, right? Animal life as well as the vegetation as well, right? So what can be the harmful effects of the ozone, right? So when it is in the troposphere, right? So one harmful effect is for the human being, right? Number one, it may cause skin cancers, right? Burning of skin cancers. So such type of issues can be there, right? Number two, it may lead to chest lungs related problems, we can say, right? Lungs related problem, which is asthma, right? Which is problem of bronchitis, etc., etc., right? So lungs related problem, right? So breathing issues, those are the problems which it may create. Okay. And the next, the harmful effect on the, we can say that vegetation, right? What will be the harmful effects on the vegetation, right? A harmful effect on vegetation, please note those down, right? I'm just, I think, dictating, right? There is no need to write here, or should I write here?
No need to write, sir.
No need to write, okay. So beta, first effect, please note that, right? Uh, leaf damage, LEAF, leaf damage, and premature aging of leaves, right? Leaf damage and premature aging of leaves, right? This is the first point, okay? And the second point, please note, a reduction in we can say, right, above and below ground growth, above and below ground growth, right? It means plant की जो growth है वो above the surface and below the surface जो होती है उसकी root की वो दोनों affect होंगी, right? Growth and biomass, right? Okay, and biomass, so that will also be affected, right? Affected. Okay, so next point is that changes in the ratio between shoot and root biomass, ratio between shoot and root biomass, including the carbon allocation, right? So carbon allocation within the plant will be affected, and shoot and root बायोमास की जो रेशो है उसमें चेंज आएगी. नेक्स्ट है रिडक्शन इन right, reduction in we can say flower numbers, reduction in flower biomass, and seed production, so that would be affected, right? Okay, So next point is that reduction in crop yield quantities, reduction in crop yield quantities, crop yield quantities, quantity and quality, right? And quality, including cereal grains, CEREAL, including cereal grains, etc. Right? Whatever it is. Next is changes in forage, FORAGE, changes in forage quantity and quality for the pasture, PASTURE, forage quantity and quality for the we can say pasture, PASTURE, right? Pasture, right? And the next point is that we can say, right? Altered tolerance of altered tolerance of the abiotic, abiotic, right? Abiotic stresses, right? Such as drought and frost, such as drought and frost, right? And biotic stresses and biotic, BIOTIC, and biotic stresses, right? Such as pest attacks, and diseases, right? And diseases. Okay. So, beta, this is a very important question for you, right? That okay, if the concentration of atmosphere in concentration of ozone gas increases in troposphere, then what may be the consequences, right? So in that respect, right, so you have to mention all these things, right? So first of all, you need to divide it in two parts, right? That effect on the human beings, right, and effect on the plants. Okay. Okay. Concentration means amount of that thing, right? Amount of one thing, right? So increase in the amount of one thing, that is the concentration. Okay. So I think it is clear up to this point to you. And beta, you must know that along with this, right, geography, we are studying the environment paper as well, right? So these topics, ozone, right, harmful effects of ozone and this atmospheric levels, right? So all these topics are in your environment subject, right? So we are studying the environment also side by side. Okay, so this is the way, right? So I think up to this point it is clear to everybody, right? So please bear in mind that ozone in stratosphere is good, ozone in troposphere is bad for the life. Okay, so now let us move on to the next point. One thing is that ozone does not exist naturally, right? Ozone is formed by the chemical reactions in the atmosphere, right? Ozone is formed by some chemical reactions in atmosphere. Okay, and those chemical reactions may be natural, or those chemical reactions may be the, right, we can say the maybe natural or maybe the anthropogenic, right, anthropogenically stimulated or caused, right? Amarnath, you're asking that how it affect pest attack. Beta, pest attack means with this the immunity of the plant would increase, the plant would become weak, right? And if the plant becomes weak, so then that means the pest attack would, right, you can say lead to the death of the plant. Okay, so that's the point, right? So now the point is that I have told you that as far as this ozone is concerned, right? So ozone does not occur naturally. It is formed by the reaction, right? By some chemical reactions in the atmosphere, right? And those chemical reactions, you can say, maybe natural reactions or maybe anthropogenically stimulated reactions, right? So that is the point there, right? So that all depends that, right, what type of reactions are those, right? So beta, let me teach you first that how the ozone is formed here, right? So beta, please concentrate here. Okay, please concentrate here what I am teaching you now. I am sharing this slide with you. Okay, sorry, sharing this page with you. Is this page visible to you all now? Please tell me. Okay, are you able to see this?
Yes, sir, it's visible.
Okay, this page is visible. Okay, so now beta, let me tell you that how ozone is formed, right? So this is the chapter which I have written on the ozone depletion completely. Okay, so this is a wonderful chapter. Okay, so so I will provide you no problem, right? So to those students. So now the better thing is that as far as the ozone production is concerned or how ozone is formed, right? So this is the point, beta. Ultraviolet radiation comes from the sun, right? ट्रोपोस्फियर में स्ट्रेटोस्फियर में और ट्रोपोस्फियर में ओजोन कैसे बनती है फर्स्ट पॉइंट इज दैट राइट सो दिस इज द फॉर्मेशन ऑफ ओजोन in the we can say stratosphere, right? So how does it happen, right? Ultraviolet radiation which is coming from the sun, right? So that reacts with the oxygen, right? And that breaks the oxygen into two, right, molecules, O plus O, right? So now the next is that O when combines with, right, another oxygen, you can say atom, right? So that becomes the O3, which is the ozone, right? So very simple process, beta. O2 plus ultraviolet radiation leads to O plus O, right? And beta, when we can say this O, right, further combines with the oxygen, then it becomes O3, which is called the ozone. Okay. I think this point is clear to you that how ozone is formed. Okay. How ozone is naturally formed. Okay. So this is the one point. Okay. Please note it. Please note it. Otherwise, you will find it difficult. Okay. So one point is that. And the second point is that which I am telling you here, right? Stratosphere. How the ozone is formed in the troposphere. As far as the formation of ozone in troposphere is concerned, this is the sunlight. Ultraviolet radiation is coming from the sun. When it reaches to the earth, what happens? Nitrogen oxide, right? It reacts on the nitrogen oxide, right? Nitrogen dioxide is here on that, right? And it, you can say, breaks it into nitrogen oxide NO plus nitrogen monoxide, you can say, right? Plus oxygen, right? Single uska hai jo molecule plus O2, right? So O plus O2 becomes O3, right? So beta, this is the reaction which takes place in this, we can say, troposphere, that how the ozone is formed, right? So in troposphere, what is there? NO2, nitrogen dioxide, in the presence of sunlight, right? It breaks into NO plus O, nitrogen monoxide plus O, right? And then O plus O2 becomes O3. This is how the ozone is formed in the you can say this troposphere, right? So please bear this in mind that ozone formed in the stratosphere is what? In the presence of sunlight, right? O2 is broken into O plus O. Then O2 combines with, then O, single O combines with O2 to form ozone, right? But as far as the troposphere is concerned, in troposphere, there is some type of different reaction, right? Here the nitrogen oxides, right, means, right? So those are broken apart in the presence of the sunlight, right? And when they are broken apart in the presence of sunlight, then you can say one O becomes separate, right? So that O combined with the oxygen, O2, right? So that leads to the formation of a O3, which is called the ozone. Okay, so up to this point, we have discussed that how ozone is formed, right? So now let us move on to the ozone depletion. right? So beta, I have given here a cycle, right? So beta, first of all, O2, O2 combined with O, ozone is formed O3, right? And then beta O3, right? In sunlight, it is broken into O plus O2, right? And then beta, it again combined with the O3, right? This beta single O again combines with O3 to form O2 plus O2, and then again in the presence of sunlight it is broken, right? And again combines, again broken. So beta, this is the cycle of ozone production and destruction which goes on like this. Please note this. Okay, please note this. Okay. So beta, this is a very mechanical chapter, right? So right, so very scientific you can say approach है, ये मैंने लिखा था. Okay. So have you noted it down? Please tell me so that I may move further. I may move forward now. Okay, so please note it, right? This is very much important for you. Right? So now the next thing is that, Geeta, have you made it, Vita? Okay, Vita, thank you. So now the, see here, O2, sunlight, O plus O, O plus O2, O3, O3, sunlight, O2 plus O plus O3 becomes O2 plus O2, and this circle goes on, right? वो जो ऊपर वाला है circle, वो वही है यहाँ पर दिखाया. Next बेटा, the destruction of ozone कैसे होती है? ये मैंने बस वही दिखा दिया यहाँ पर जो पीछे उसमें लिखा है, right? Circle में. So now beta, here is the anthropogenic reason, right? Anthropogenic reason. Yesterday I told you that there is one thing which is the these fluorinated gases, right? Fluorine gases, which is the chlorofluorocarbons, perfluorocarbons, right? So hydrofluorocarbons, hydrochlorofluorocarbons, right? So these are the gases. So see how these gases react here, right? So this is the chlorofluorocarbon, right, which reaches the upper stratosphere, right? Sorry, which reaches the, you can say stratosphere, okay? So whatever the gas, right, synthetic gas, right, which is the ozone depleting substance, we say these, whatever the ozone depleting substance is produced on the earth here by us, right? So that takes 2 to 5 years to reach that you can say stratosphere, right? So it means whatever ozone depleting substance we are producing here today, right? So that may start harming the that you can say ozone in the stratosphere, right? After 2 to 5 years, right? And then the cycle goes on, right? Some of the gases, particularly these जो chlorofluorocarbon, perfluorocarbon, hydrofluorocarbon, etc. Yes, these you can say fluorinated gases. So these gases have a lifespan of right from you can say 50 years, right, up to you can say hundreds of years also. So beta, therefore, once they enter into atmosphere, right, they keep on damaging the ozone, right, for you can say more than 50 years, right, and it may go up to the 100 years also, right? So that is why this is worrisome. Okay. So now see, this is sunlight coming from sun, right? So here is the chlorofluorocarbons, CF2Cl2. This is the formula, right? Chlorofluorocarbons, CF2Cl2. So now what is there, beta? In the presence of the sunlight, what will happen? One Cl2 will be separated and CF2Cl will remain there, right? And beta, this Cl, right, when combines with this O3, ozone, right? So then beta, it breaks apart this, we can say ozone, right? And beta, here is made ClO plus O2, right? So oxygen plus this chlorine oxide, right? It is made. And then beta ClO, right? Combined with this, we can say O also, right? So beta, again what happens? ClO2 is there, right? And then ClO2 in the presence of the sunlight, again broken Cl plus O2, right? And this cycle goes on like this, right? So once the cycle starts, so, right, it keeps on moving for a fairly long period of time. So that is why this is quite harmful. Okay. So please note beta this also. Uh, Either note these equations, right? Or you can make this figure also. Okay. So this is your choice. Okay. Yes, sir. Sorry means Santosh. Yes, beta. Depletion process. One is this. One is this process, right? Ozone is broken by the ultraviolet radiation into O2 plus O, right? So this is the loss of ozone, we can say, right? Again formed, and you can say again broken. So beta, we can say that, right? This part of the diagram, right, which is on the left hand side, please focus on that, right? Beta, it means that if it is the formation and destruction of we can say ozone due to the nature, right, due to the natural reasons, so then beta there remains a balance always, because see here beta, on the one hand, right, it is depleted, right? O3 is broken into this, and then beta O again combines with this O3, right beta? Then it again makes O2 plus O2, right? Then beta again, the O2 will combine with O to form this, you can say ozone, right? So beta that almost remain in balance. And beta this side is what? Which is the anthropogenic gases, right? Synthetic gases, which I told you yesterday that the chlorofluorocarbon, we are taking the example here of that chlorofluorocarbon. Okay. Yes, I'm coming down. Okay. So beta, this is the point, right? Please check it. So ultraviolet radiation of the sun, right, means CF2Cl2, right? When it is exposed to the sunlight, right, then it is broken into the CF2Cl plus 1Cl, right? And that goes separate. Okay. Now this Cl combines with the ozone, it makes ClO plus O2, right? Chemical reaction, right? And now this ClO combines with O again, it makes again Cl plus O2. So the ozone is depleted, right? O3, right? O3 is lost now, right? Which was here O3, right? So this O3 has lost now. So beta, this is the pointer, right? That you can say how the ozone is depleted there. Okay. So I hope it is clear to you. Okay. This is the ozone, how it is depleted, right? Otherwise, better this you can say cycle is also quite easy, right? If you can bear this in mind. Okay. So this is the way that how the ozone is depleted, right? So I hope this is clear to you. Okay. So now the point is that, right? So ozone depletion and ozone formation, I have told you in brief, right? So if anybody needs to draw it, you can draw it, please, right? So this will help you, okay, in understanding the things in a more clear and better way. Okay. So I'm moving forward now. If anybody needs to wants that I should stay here, you please tell me. I can stay here for some time. Okay, so beta, this is the point, right? Rest of the things we will do later on, right? Ozone hole formed, how, what is that, right? So those things are not part of this, right? So beta, that is why seeing the increased concentration of the, right, seeing the increased concentration of we can say of the ozone depleting substances in the stratosphere, right, which are causing harm to the ozone there, right, because a very large ozone hole was developed over the south, near the south pole, right? So though ozone holes are there everywhere, right, it is near the north pole also, right, it is some at other places also, but the ozone hole which was developed near the southern pole, that was quite large ozone hole. So that is why, right, scientists were, you can say, worrying about that, right? And it was in the 1970s, right, that we can say the scientists started noting that that whatever the synthetic gases we are producing here, right, which we are using for the refrigerants, right, in the refrigerants, in the, we can say, air conditioners, right, or you can say in the fire extinguishers, right, etc., etc. So those gases, right, when you can say released into the atmosphere, right, so they create harm. How? They got concentrated into the, you can say, stratosphere, right, and there they react with the sunlight, right, react in the presence of the sunlight. They are broken apart, and the process of the ozone depletion starts there, right? So beta, that is why in 1987, right, one, you can say, Montreal Protocol was adopted by the countries, right? In 1987, right, the countries adopted one Montreal Protocol. Okay, Montreal Protocol. Montreal is in Canada, right? Canada. So the purpose of adoption of this Montreal Protocol in 1987, right, was to, you can say, reduce the, right, was to stop the, right, production of these, you can say, gases, or we can say ozone depleting substances, right, that are creating harm to the ozone there in the atmosphere. Okay, so this Montreal Protocol, which was signed in 1987, that you can say came into force in 1989, right, in 1989, right? So beta, please bear this in mind, that Montreal Protocol is, we can say, associated with the ozone depletion, right, associated with the discourage of the production of ozone depletion substances, right, on the earth. Okay, so beta, this is the point, right? So today we have discussed these important points, right, related with this, you can say, this stratosphere and this troposphere, right? So beta, any doubt to anybody, please, you can ask me, right? So now it's open for you. Okay, so I tried to explain it in detailed manner. So if still any doubt anybody has, please tell me. Okay, so, right, so have you enjoyed the lecture or not? Please tell me.
Yes, sir. A lot.
Yes, sir. बहुत अच्छा lecture था.
Yes, sir.
Okay,
Yes, sir.
okay, good, beta, good. Because the lecture is for you only, right? So if you are not getting, then there is no purpose. Okay. So beta, kindly revise these things, right? Once after the class, right? Or in the evening today. Okay, so that's good. Okay, so I think that slowly, you must have been developing interest in geography as well, or not? Geeta, is it?
Yes,
No,
sir.
huh? No, no? Geography seems difficult for you, huh? Is it? Okay, okay. No.
Sir, it is the best of all the subjects available in civil services.
Basically, yes, but some persons don't have interest, na? Okay, okay, good, beta, good, Geeta. If you are now developing interest in this also. Okay, okay, good, good, very good. So this is a good approach, that nothing seems difficult for me. Okay, this is good approach. So this will help you to reach your destination. Okay, so rest of the students, these Amarnath, Vicky, Shubham, Kusam, right? Kusam is new today. Okay, and then Ayman, Sakshi, Pooja, Navreet, Gursimran, Geeta. Geeta has already conveyed. Bhavesh, Abro, Akanksha. So tell me, beta, please. Us, right? Asika, Santosh is okay. Arshita, tell me, right? So that, right? So that at least राइट, मेरे मन को शांति मिले कि मैंने आज ठीक डिलीवर किया है आपको, राइट, एंड आपके काम आया है जो आज मैंने आपको बताया है. सो दैट इज द पर्पस ऑफ माई, राइट. ओके, so if I could not be able to deliver up to your satisfaction, so then what happens, then I got a little tensed, right, after the class. And right, and next day जब मैं उसको मतलब कवर नहीं कर लेता, तब तक फिर मुझे टेंशन रहती है कि नहीं मैंने आज अच्छा नहीं पढ़ाया, है ना. So that's why. Okay, good. And some of you might have been geography students, na, during your graduation as well, right? So who remained student of geography during the graduation? Okay, thank you, Pooja. Okay, nobody is geography student. Okay, right, beta, right. So, okay, beta, I am taking leave now, right? So, okay, Santosh is pharmacy background. Okay. So I am leaving now, right? And you will receive the link of this class by the evening today. Okay. So if anybody has any doubt and want to repeat the lecture, you can repeat your lecture, right, on the YouTube also. Okay. So that's not an issue. Okay. Amarnath, you are from England. Amarnath?
Sir, English literature, sir.
Pardon?
English literature, sir.
Okay, okay, okay. English literature. Okay, that's why England you are mentioning. I thought that if you're from England, then why, right? You are trying civil services over here, right? That is a very nice country, climate-wise also. Very good
No,
country.
sir. India is best, sir.
Okay, India is best. Okay, okay, okay. Thank you. Good, great. Okay, beta. So we will. I will see you tomorrow again at the same time.
Thank you, sir.
Okay, ozone notes today. Ozone notes, yes, yes, I will provide you. Don't worry. Okay, don't worry. I will provide you.
Good noon, sir.
Good noon, beta. Take care.
Thank you, sir.
Thank you. Welcome. Stay healthy.
Thank you, sir. Thank you, sir.
Welcome, beta. Welcome to everybody. Okay.